Hello, good afternoon. If you're here early, you can get yourself a cup of water and maybe wait for another 3 to 4 minutes. And we'll start very soon. Well, I see some familiar faces from yesterday's lesson. Oh, hello. Hi, Wenxuan. Didn't know it was you. Hey, so today we'll be talking about the number theory. Yes. So if you have the book, you can turn the book to page 151, where we will be starting talking about the prime and composite numbers, right? Oh, hi, all familiar faces. Okay. So please give me another 3 minutes. All right. Maybe before we begin, yes, page 151. Let's start with a round of easy quiz. Okay. So guys, how many prime numbers are there between 1 and 100? A small quiz before we start. Um, am I? 51. I got the answer as 51. Oh, 25. Hello. Yes, the correct answer is 25. Okay. Um, well, I see. Uh, it's 25. It's 25. It's not 51. Thank you, Nathan. All right. But no. All right. Yeah, we just start. All right, so we just got started with an easy question about prime and composite numbers. If you are in our online class, I'm sure you have played the. Well, can somebody mute Nansen here in the YouTube? All right, so guys, um, if you are in our online lesson, sure you have played the 5 times 5 shoulder table where it contains all 25 uh contains all 25 prime numbers between 1 and 100. All right, thank you guys. So let's start with our today's new topic about the prime and composite numbers. Now, for prime numbers, guys, what is the definition of prime numbers? What is a prime number? What kind of number we call them prime numbers? What kind of number we call prime numbers? Prime numbers are those, yes, indeed. Prime numbers are those with exactly two factors. I can only be divided by one. Well, we should be specified that it can not only be divided by one, but also itself. And also we have to specify that it has exactly two factors, because one can only be divided by one and itself, but it's not a prime number. Okay, so this is not prime. Okay, then for those who are not prime numbers and one, all right, for those with more than two factors, we call them the composite numbers. Okay, so actually, whenever you see a prime number and composite number kind of questions, right, you should immediately think about some very, very key important things. That would be the odd and even parity. Okay. So guys, when I mention a prime together with even, what would you think about? An even prime. What is the number that pops up in your mind? An even prime? Yeah, the even prime can only be 2. All right, this is the special one. This is the special one. Even prime is 2. Yes, where people saying, do I have class later? No, this week we don't have class. Okay. So actually with this concept only, you can already solve a lot of questions. For example, the first question in our prime and composite, not the first question, here. All right. The first example. Now, with the idea of even and odd, you can already find out the answer of this question. Why? Because you see, we have 3 times a prime number, 5 times a prime number. In the end, we get an odd number. Okay, guys, what do we know about two numbers adds up to an odd number? Can it all be even? Can they all be even? No, they can't all be even. There must be one even and one odd, right? So we must have one odd number and to plus one even number. Right, so that's why in this question, you'll see that, well, since we know the even prime can only be 2, right? The even prime can only be 2. That's why in the second step, we already jump directly to have a try. If P equal to 2, if Q equal to 2, what happens? And then find out the value of P and Q, right? So actually, the odd even parity can already help us find out the value of find out the answer of many questions already. Okay, so I got a question says which page is this? This is page 153. So actually, same for the next practice question. If you want to have a try, you'll see that this is an odd number, and hence we know that one of these will be odd, and another one will be even. All right, so it will be odd plus even. All right, excuse me for a second. Okay, sorry. Got a sudden meeting call. Sorry, I got a sudden meeting call. Okay, so yes, Lisa, I do remember you. All right, so guys, This will be the first important thing about the prime and composite numbers. Okay, so I think yesterday we had a very good thing as about the rating the questions, right? So guys, why don't you just rate this question again? Now we're only using the odd even property, the odd even property to solve the question. Okay. Well, am I lagging? Give me a second. Guys, am I lagging? No, I think I'm lagging. All right. See, how can I handle this? Guys, please give me one moment. Let me get my internet improved. Okay. Okay, guys, it's now better. If it's getting better, please maybe type a yes in the chat. Let me know. Is the Wi-Fi getting better? No. All right. I have no idea what is going on. Um. Oh yes, a bit. Okay. So let's just move on. All right. So this is the first important thing. Now, for the second important thing is about the prime factorization. All right. So I believe in the school, or if you are studying with us, we taught you that we can use. All right, we taught you that you can use a ladder method to do the prime factorization. Right. So for example, 24 here. Now, if we divide by 2, that is always, we start with the smallest. It's always we start with the smallest prime factor of 24, right? And then 12 divided by 2 again, 6, 2 again, and a 3, right? So this is how we get the prime factorization of a number, right? Now, before we move on, all of these competitions, they love to test about the year number, the prime factorization of year number, right? Okay, so guys, let me test you a little bit, which is something that we did earlier, yesterday. What is the prime factorization of 2025? Yesterday, I remember I said one thing that is 2025 is actually a square number, right? So is what is the prime factorization of 2025? Okay, we have people says it's 45 square. Thank you. So this is 45 square, right? So if you want to remember what is the prime factorization of this, we know that each of the 45 can be written as, 45 is just 5 times 3 times 3. So 3 squared times 5. Now this is 45, and then we'll take the square. All right. So the factorization of 2025 is 3 to the power of 4 times 5 squared. Okay. Now at least try to remember this, because every year they all love to test you about the prime factorization of the year number. All right. So so please try your best to remember this number at least. Right. So for the prime factorization, actually, will also leads to a very common question, that is the number of zeros at the end of the product. Now, guys, think about this question first. What kind of number What kind of number have zeros at the end? What kind of number will end with a zero? Why we already have people with brain cells when population went down already? That's a bit too early. Guys, odd number 10. Okay, it's a multiple of 5 or multiple of 10. Okay. Yes, actually, all the number that ends with 0 will be a multiple of 10, right? So that is saying if I give you a random number, let's say 9987. Now, if I want to end with 0, I times by 10. Now, if I want to end with 2 zeros, I need to times 100, right? Which is 10 times 10, okay? If I want to end with 3 zeros, then I have to times 1000, which is 10 times 10 times 10, right? So actually, a number times 10 will give us a 0 at the back. But then, how can we get the 10? We get the 10 from, yes, we already have people saying it's an even number multiplied by 5, right? So we get the 10 from 2 times 5. So after you do the prime factorization, how many pairs of 2 times 5 you have will determine how many zeros you have at the back of the number, right? So this is the idea. This is the idea of the number of zeros at the end of the product. So let me give you an example. Okay, so for example, if I tell you I have 2 times 2 times 2 times 2, and there are 2025 twos times together, and also times 5 times 5 times 5 times in total of 2024 fives times together. Okay, guys, in this case, my product will end with how many zeros? If I have so many twos and so many fives, right? Am I lagging or? We're talking about the topic 18. Topic 18. N zeros a lot, 800, 2024. Okay, so actually, like I said, all we need to do is think about how many pairs of 2 times 5 can we form, right? How many pairs of 2 times 5 can we form? So in a pair of 2 times 5, all I need is a 2 and a 5, right? So if I have 2024 fives and 2025 twos, that means I can form 2024 pairs of 2 times 5 with an extra 2 left, right? So I just pair them together and I can definitely form 2024 pairs with, because I have an extra 2 in the end. That's why I will get an extra 2 in the end of my product. So if you say, what is the result of this question? That would just be 2 followed by 2024 zeros at the back. 2024 zeros at the back, right? So this is like the basic type of question. Of course, I can make the question a little bit more complicated by, right, instead of giving you 2 and 5 directly, I can give you another numbers, and then you need to do prime factorization to find out how many 2s and how many 5s are there in total. Okay. All right. So let's, before we move on, guys, as you can see here, I have a little bit more 2s then a little bit more fives, right? I have more twos than fives. So actually the number of zeros is determined by the smaller amount. Here, I have less five. So the five will determine how many zeros at the back, right? How many zeros at the back. But guys, don't look at the camera. I'm not good looking. Don't look at the camera, all right? So that's why let's move on to our explore 2. Not explore 2, example 2. That is, if I multiply from 1 to 200, 1 to 200, all right? How many consecutive zeros are there in the last digit of the result? Now, from the last example, we already see that all we need to do is to compare the number of the numbers of twos and the number of fives, right? Which one is less than it's laggy? Why? Yesterday went well. Okay, now let me change my internet, guys. Oh, is it getting better? Hi, guys. Is it getting better? Oh no, what is this? Hmm. I think this is like already the best I can do. I've already changed the internet. Hopefully it can get better. Okay. Hopefully it can get better. All right. So we just need to find out we have more twos or we have more twos or we have more fives. Actually, if you are from our P4 lessons, we just learned this like 2 weeks ago, right? Even though I know many of you have a short memory, but please try to review what we have done in the lesson. So normally, all right, guys, I'm not sure if you have learned this or not, but have a guess. If we have 1 times 2 all the way to 200, after we do the prime factorization, after prime factorization, all right, we'll have more twos or we'll have more fives. Guys, which one will be more? After we do the prime factorization, we'll have more twos or we'll have more fives. All right, if you think the answer is 2, just type the 2. If you think the answer is 5, just type the 5. Let's see, what do you guys think? Okay, where people say 2. Me too. Yes, excellent. It's 2, right? We'll have more 2s. Why will we have more 2s? Why will we have more 2s? Because you see, every 2 number will get at least one multiple of 2, right? 1, 2, 3, 4, 5. Every two number, we get a multiple of 2. But only every 5 number, we will get a multiple of 5, right? So that's why, why is this line here? Right, that's why in most of the cases, we will have more twos. But just now we said the less amount will determine how many zeros. All right, So that's why actually we don't have to think about how many twos are there. All we need to do is just find out how many fives are there, and then it will determine how many pairs of 2 times 5 are there. All right, so let's just go ahead and find out how many fives are there. Okay. Yes, actually the answer are here. There are fewer fives than twos. So how can we count the number of fives? Now you can first think about this. What kind of number will give you a 5 after doing the prime factorization? What kind of number will give you a 5 after doing the prime factorization? It will be multiples of 5, right? So for example, 5, 10, 15, 20, all of these numbers, after we do the prime factorization, we will get a factor of 5. Right? It will get a factor of 5. So that's why we only need to find out within 200, how many multiples of 5s are there? How many multiples of 5s are there? Yes, 200. All right. So you can follow the steps here. You can see that, first of all, there are 200 divided by 5. That is 40 multiples of 5. Right? So every multiple of 5 will give us 1 factor 5. By 1 factor 5, I mean every time we're doing prime factorization. Right? So after you do prime factorization, sometimes, for example, 15, after you do prime factorization, you will get a factor of 5. This is called a factor of 5. Right? So every multiple of 5s will give us 1 factor of 5. So we see there are 40 multiples of 5. That means we will get 40 factors of 5, right? But then why are we doing all of these? Guys, think about a special case, 25. What is the prime factorization of 25? What is the prime factorization of 25? All right, the prime factorization of 25, everybody knows it will be 5 times 5, right? So in this case, how many 5 do we get? Actually, we get 2 factors of 5. 2 factors of 5. So you see, even though every multiple of 5 will give us 1 factor of 5, but for those multiples of 25, they will all give us 2 factors of 5, an extra 5, right? So for example, 50. 50 will also give us an extra 5, right? 75 is the same. It will give us an extra 5. So we need to find out how many multiples of 25 are there. Okay. That's why we can, here what we did is 40 divided by 5, but also you can use 200 divided by 25. You'll see that this equal to 8. That means we have 8 multiples of 25, which will give us 8 extra 5, 8 extra factor 5 here. A factor 5 here. So originally we already had 40, but now we have 8 extra, so we need to add 8. But we're not done. We're not done. Okay, I know that I'm killing the brain cells, but we're not done because since 5 times 5 will give us an extra 5. Now how about 5 times 5 times 5? Think about it. What is 5 times 5 times 5? 5 times 5 times 5 is 125, right? It's still within, it's still between 1 to 200. So we still need to count this extra 5. All right. When people asking why is it extra? Because for example, for 5, 10, 15, for all of these multiple of 5s, right? After we do the prime factorization, 1 times 5, 2 times 5, 3 times 5, you'll see that there's only one factor of 5. So when we count all the multiple of 5s, we count it as only one factor of 5. But there are some numbers with two multiple of 5, with two factors of 5s, with two factors of 5s. All right. So you see, this one I have 1, this one I have 1, this one I have 1. But when we come to 25, I actually have 2. But just now, we have count only one of them. That's why we need to find the multiple of 25 and count the extra one. Okay. So let's come back to the 125, which will give us another extra one. So in total, we have 40 at the very beginning, extra 8 from the multiple of 25, and an extra 1 from the multiple of 125. All right, so that's why the answer is 49. Okay. Now, if you think you are cooked, right, guys, do a simpler version of this. The simpler version would be you start with question 1. How many zeros would you get at the back of 1 times 2 times 3 all the way to 15? All right, this is question 1. And then the second simpler version would be 1 times 2 times 3 times all the way to 25. How many zeros at the back of these numbers? So if you find this example question complicated, now have killed your brain cells, guys, let's just start with some simple and easy question where you can just do the prime factorization and find out how many zeros are there. Yes, I guess today we are definitely taking a break, maybe after 1 hour. Today will be a little bit more difficult than yesterday. Okay. So the part 1 and the part 2, if you want to try this question, right? I highly recommend you to try part 1 and part 2 by yourself first. And I'll leave my answer here. The answer for part 1 is 3. The answer for part 2 will be 6. Okay? The answer for part. So please do these 2 warm-up questions and then move on to the actual practice here. All right, guys, it's rating time. Let's give this question a rate for 1 to 5. Let's see what will be our rating for this question. Actually, if you've done this question, I think this would not be a big issue. The page 155. 5. Okay, 3. Okay. When people spamming the chat box says 5. I think right after you get the idea of this would be more like a level 2 to level 3 type of question. Okay. All right. So if you still have trouble understanding the example question, please, like I said, start with these 2 easier examples to find out the pattern and see how it works. Okay. So this will be the common question type we'll see in NMOS. Common question type we'll see in NMOS. Now you'll see similar questions at the back. So after you are done with the example question, after you fully understand the example question, please go ahead and try the example questions at the back where, well, I'm gonna say that this question could be challenging. This is actually really challenging. Okay, so if you have any question trying this one, if you have any question trying this one, please find me in the group or find another teacher, your teacher, okay, in a group, ask them how to do this one. Okay, this is our actual challenge question. Okay. Okay, so let's move on. We move on to the next topic, which is about the remainders. Right. So let's start with the most basic remainder property. Okay, what is a remainder? No, you don't use a calculator. Guys, you don't use a calculator. I mean, everybody wants to use a calculator, but please don't. All right. Well, I'm sorry if you still get confused. You can try the easier question. As I mentioned earlier, okay, you can try the easier question. Find out the pattern here. Okay, so we start with the remainder property. Guys, what do we know about remainder? Or what is a remainder? Oh, we can't use calculator, guys. We can't use our calculator. What is remainder, guys? Remainder is when you cannot divide a big number evenly, right? So 10 divided by 3 equal to 3 remainder 1. Oh, so nice. Okay. So we know that the names of four of them will be the dividend, divisor, the quotient, and the remainder. I'm kind of lazy to write it all of them done. But yes, here are the four things. Now, the basic remainder property will be about the relationship between dividend, divisor, the quotient, and the remainder. Okay, so an easy question type. Maybe many of you might have found in SASMO or in your school paper. That is, if I give you the divisor, I give you the quotient, I give you the remainder, how to find it out? Yes, if you want, please write it down. Right? How to find out the dividend? So, for example, let me give you a divisor equals to 10, while the quotient equal to 12, and the remainder equal to 7. So, guys, in this case, what will be my dividend? Oh, SASMO next Thursday. Well, good luck to you on that. 127. Yes, it's just 127. Right. Okay, so you see, we always start with some easy questions about the remainders. Now, for the remainders, guys, while I was writing this, I was thinking about some strange numbers that initially, this 13 comes up to my mind as the remainder. But guys, can 13 be the remainder here? Can I replace the 7 with 13? Can I? Can I replace my 7 with 13? So you do the same. Why? Why cannot? Why cannot? Very good. 13 greater than 12. So the remainder cannot be greater than what? The remainder must be smaller than, must be smaller than, not actually 13. It must be smaller than the divisor, right? Must be smaller than the divisor, 10. Why is that? You see, when we use division, right, it's same as I have 127 apples. I want to divide them into 10 in a bag. right? But if I have say 13 apples remaining in the end, that means I can get another new bag of 10, right? So if the remainder is bigger than the divisor, then it will just add to the quotient. It will add to the quotient. Okay, so it makes no sense for the remainder to be bigger than the divisor. All right. Now, this is like the basic of the remainders. Now, today we'll be more focusing on what is the remainder property. Okay, so guys, let's just say I'm thinking of a random number, 172. Okay, so guys, what is the remainder of 172 divided by 9? Somebody help me calculate the remainder of 172 divided by 9. Please, please. 172 divided by 9, you will get a remainder of 1. Right? You'll get a remainder of 1. Right? Now, how about 172 plus 172 and then divide by 9? What is the remainder of 172 plus 172 divided by 9? 2. Okay. A remainder 2. Okay, maybe you can calculate this. Now, what if we have 172 plus 172 plus, okay, in total, 172s added together. Then what will be the remainder? Three. A 3. We have 7 of these numbers added together. 7. Okay. Well, I'm sure that you didn't really calculate what is the sum of 172, 7 172s, and then divided by 9, right? So actually, how can we do this is we have the remainders have a very important property that is called additive property. That is, the remainders can be added together, or if I write it down, that is the remainder of the sum is equal to the sum of remainders. Right? So for example, the 172 plus 172 divided by 9, I can just write it as it's remainder 1 plus remainder 1, which will give us remainder 2. This is called the additive property. Right? Now, same here, 172 plus 7 172s times together, I can write it as R1 plus R1 plus 7 R1 plus together, and I'll get R7. All right. So this is the remainder property. This is the remainder properties. First remainder property. Now, guys, actually, right, 172, if I add 7 172 together, you can also calculate it as 7 times 172. Right? So does that mean our remainder is also 7 times remainder 1? So here comes another property of the remainders that is called it's multiplicative. Multiplicative. Okay, it's similar phrasing, and it's just I changed the sum to the remainders. The remainder of product is equal to the product of remainders. Okay, remainder of product is same as product of remainders. So I would like to give you another example. Okay. Okay, guys, I'll need your help to do another round of calculation for me. First of all, okay, people, we have two different platforms, people on WeChat and people in WhatsApp, right? So people from WeChat, please help me calculate what is the remainder of 172,659 when divided by 9? Okay, and also for people from YouTube, please help me calculate what is the remainder of 987,654 when divided by 9. Okay. What would be the remainder of these two numbers divided by 9 separately? And I want to know, what I want to know is, what is the remainder of the product when divided by 9? A 3. Okay. All right. So we have people on what WeChat says this one has a remainder 3. Yes, it has a remainder 3. Okay. How about people from how about people on YouTube? Remainder 1? Is it remainder 1? Quotient is 1. I don't think this one has a remainder 1. 98765. Does it have a remainder 1? No, it's not remainder 1. It's remainder 3. Okay. Okay. This is remainder 3. Remind you a little bit. Actually, I'll talk about this one later. Remainder 1? When divided by 9, should be remainder 3, right? Okay, yes, remainder 3. Okay, so actually, I'll talk about this one later. When you determine the remainder, you can also use the divisibility rule to help you a little bit. Divisibility. All right, but that's our next topic. But here, let's just focus on the remainder property. All right, so guys, have a guess. My final remainder will be remainder how many? My final remainder will be remainder how many? Based on what I just told you, right? The remainder of the product is same as the product of the remainders. So we are looking for the remainder of a product. So this will be same as the product of remainders. Okay, I got answer. R6, R9, R0. Guys, we are doing times here. So the remainder should also times together. Right? You're not adding them together. Okay, so R3 and R3, that will be, seems like it will be R9, right? But guys, can my remainder be 9? Actually, if you have a remainder 9, that means since we're divided by 9, that's another group, right? So it's another group, and R9 will be same as R0. Okay, so the answer will be 0 here. Be careful. Be careful. Okay, so this is the remainder property. Okay, so let me give you a summary that the remainders can be added together, can do subtraction, can do multiplication, but cannot do division. Okay, so you can add the remainders together, you can multiply the remainders together, you can do the subtraction between the remainders, but guys, no division, absolutely no division. Okay, so with this remainder properties, together we can take a look at, wow, this question. Yes, we will have the break very soon. I can tell that some of you have 0 brain cells survived. But maybe another 15 to 20 minutes. Okay. So take a look at this question. Looks super scary. All right. But guys, don't get scared. Whenever you see the big numbers, normally you can find a pattern of the remainders. Okay, there will definitely be a pattern of the remainders. The question will not ask you to calculate it one by one, calculate 2 to the power of 2021. That's not realistic. Right? Yes, we will do the rating definitely. Okay, so let's try to find out the pattern of this one first. And this is page 161. Right, don't be scared, don't be scared. Let's start with 2 to the 2021 divided by 7. What is the remainder of this one? Right? What is the remainder of this one? So actually, like I said, we can observe some patterns of the remainders when power of 2 when divided by 7. 2 to the power of 1 divided by 7 has a remainder 2. Now, of course, I've done all the calculation here for you, right, on the book. 2 to the power of 4 divided by 7. So this is 2 divided by 7, 4 divided by 7, 8 divided by 7, 16 divided by 7, 32 divided by 7, 64 divided by 7. All right. Seems, guys, what is the pattern here? Look at the remainder of all of these when divided by 7. What is the pattern? What is the pattern you can see in this? Oh, easy. I already see some people says easy as long as you just find out the pattern. It's 2 for 1, 2 for 1, right? 2 for 1, 2 for 1. So three powers in a group. Right now, we have all the way to 2 to the power of 2021. Right? 2 to the power of 2021. So all we need to do is like find out how many groups are there and the 2021 is corresponding to which one of these in the group, right? So we can do 2021 divided by 3. Since we have 3 in a group, that will be 673, remainder 2. That means we have 673 groups of 2, 4, 1, right? And another 2 remainders, another 2 remainders in the cycle. So the next 2 will be 2, 4. So this 4. The second one, since we have a remainder 1, we'll have the second remainder in the group as the remainder of 2 to the power of 2021 divided by 7. Right. So I don't know the quotient, but I know that this has a remainder of 4. Okay. So as long as you find out the pattern, should be okay. All right. So we're done with the first scary part. That is 2 to the power of 2021. Now we're not done with the whole question because we still have the 2021 squared to determine. All right, what is the remainder of 2021 squared divided by 7? Now, I don't think that you really want to calculate what is 2021 divided by 7. But here, what do we have? We have a multiplication, right? Just now we said the remainders can be multiplied together. So actually, you can make it simpler. We start with what is 2021 divided by 7? What is the remainder of this? So what is the remainder of 2021 divided by 7? Oh, I just realized that it's on the book. Yes, it's the multiplication rule. All right. So it will have a remainder 5. So this is saying, well, remainder 5 times remainder 5 will be the remainder of 2021 times 2021 when divided by 7, right? So guys, what is remainder 5 times remainder 5 times remainder 5? What will be remainder 5 times remainder 5? So remainder 5 times remainder 5 will be, seems like 25. But the question comes back again, can the remainder be 25? Can it be 25? I see everybody is texting 25. But can the remainder be 25? No, it can't. Right? It can't. So because 25 is bigger than our divisor, right? So we can actually pack this 25 into another several groups of sevens. That's why to find out the actual remainder, we have to do 25 divided by 7 again. And then we can get our actual remainder, which is 4. Okay. Yes, I have a lot of people saying it's 4. Yes, good job. So now let's come back to the very beginning of the question. We know that this one have a remainder 4. We know that this one have a remainder 4. Okay, so guys, what is the remainder of this n, which is the sum of them when divided by 7? Be careful, guys. Be careful. I'm expecting to see the correct answer. R4 plus R4, and hence we will get the remainder of n divided by 7 will be R4 plus R4, right? So that will be R8, but can we have R8? Can we have R8? Can we have a remainder 8? So is it correct for me to write down the answer of this question? That is 8? Not really. All right. So once again, we need to use 8. 8 is bigger than 7. So we need to use 8. 8 divided by 7, which will give us 1 remainder 1. So the actual remainder will be 1. Okay. All right, so guys, yes, it's your favorite time to rate the question once again. Guys, let's give this question a rate from 1 to 5. How hard do you think the question is? 1 for easy, 5 for killing brain cell. 5.5. Okay. All right. Yes. Today I think I received more 5s than yesterday. Today is getting harder. Yes, indeed. Okay. So anyway, this is what we have for the remainder property. And I know that you're waiting for a short break, right? So for people who want to take a break, yes, please go take a break. We will be back very soon. And since we have maybe another 1 hour discussion of the number theory, right? So guys, please stay here, stay tuned in. Please do not leave, and we will be back very soon. Okay. Not really, not really. We still have 2 other topics. All right. So don't go away. We'll be back. Uh, guys, in 5 minutes. All right. Let's start in 5 minutes. Of course, if you want to chat with me, let's just chat in the chat. Let's check. Just check here. Well, I have a question. Overall, how many topics have you all complete at the moment? Guys, how many topics have you completed at the moment? Don't know. A lot. Have you watched the challenge videos? Has anybody watched the challenge videos? Zero. Well, if you have watched any of the challenge videos, feel free to share. Who's your favorite video recorder? Which teacher is your favorite video recorder? Me. Oh, thank you, Lisa. Teacher Ethan. Okay. Teacher Yuxin. I think Teacher Yuxin is probably here. Is she? Maybe. Well, we got a Yuxin fan here. We also got a Teacher Ethan fan here. Oh, you love topic too, at most. Yeah, it's a fun topic. The new definitions are definitely a fun topic. All right, if you haven't watched any of the videos yet, maybe you can share your opinions later. Who's your favorite video recorder? Let's see who's popular. Oh, you like fraction? Okay. Oh, teacher Belinda. Well, I can't even remember which question I recorded by teacher Belinda. Some, yeah, definitely some. I can't remember which one. Maybe time to buy some coffee for the popular video recorders. Okay. Thank you, Lisa, but I'm not gonna buy coffee for myself. By the way, I think you probably haven't even watched my videos. They're quite at the back. Okay, let's just take maybe another 2 minutes break. Okay, I also need to get some water. Chapter one, overall, the calculation chapters topics will be slightly easier than others, and also the word problems might be slightly easier than others. Oh, thank you, Lisa. Yes, I also like Fibonacci sequence, but I don't think it's often frequently tested in NMOS. That's why we don't have a topic specifically for that. Uh, Great to see you back. All right, great to see you guys get back. Give me 10 seconds. Let me get a cup of water and I'll be back. Okay, you can now look at my cute camera background. Yes, I'm back. Now let's get started. Okay. Yeah. Well, like I said, if you have a question you don't know how to do, feel free to share the question in a group. Right? We have the WhatsApp group. We have the WeChat group. Feel free to share your question, and I think there will be a lot of teachers who are very, very willing to answer your questions. Okay? If you are asking which one is the hardest, um, definitely going for IMO. IMO is definitely the hardest one. Okay. All right. So let's come back. Let's come back to the congruence problem. Uh, where you'll see a congruence is actually about same remainder, right? So let's once again start with the easy question. So let's say 27 divided by a fraction which I don't know gives you a remainder 2. Okay. And also 102 divided by, no, 102 is not very good. 112 divided by the same number gives me a same remainder of 2. Okay, so you see, this time I got two numbers divided by a same divisor, and they all give you a same remainder of 2. Now, this is called a congruence, or congruence. Now, if you are familiar with some of the notations that normally in maths, we can write it as 27 is congruent to this when mod n. Okay? Of course, for most of you don't have to think about this. Well, I see a lot of you were texting already. We're texting already that the n equal to 5. How do you get n equal to 5? Hi, we've talked about the questions in topic 2, I think yesterday. How do you know that n equal to 5? Right? So actually, whenever we have same remainder, the idea is since we can do addition, subtraction, and multiplication of the remainders, right? We can actually try to get rid of the remainders. So guys, now I think if I use 27 minus this remainder 2, now what do I get? I will definitely get a number that divided by n with no remainder, right? Or I can call this 25 is a multiple of n, right? So in this way, I can say 25 is a multiple of n. Okay. Now I can do the same thing for the 112. I get rid of the remainder. That'll be 112 minus 2 divided by n. Now definitely also have no remainder, right? So that is saying 110 is also a multiple of n. Okay, so in this case, we know two multiples of n. That's why for the n, we can just look for the HCF of these two numbers, 25 and 110. And that's why, yes, it can only be 5, right? N can only be 5. Okay, so this is the idea of same remainder problems. So what? Sorry, what am I writing? N equal to 5. Okay. Okay. The same remainder problems. We generally have a common idea that is we get rid of the remainders. We get rid of the remainders. Okay. So now the question here is nice, right? The question here is nice. Now you can also see some kind of question that don't tell you the remainder. For example, let me just randomly write down another number here. Let's say 60, 67, 81. Sorry, not 67, 65. All right. 65, 81, and maybe 100, and I'm doing a calculation. I'm literally doing a calculation. 153. Okay, so let's just say these three numbers that when they divided by n, they all have the same remainder, but unfortunately, I forgot what is the remainder. Let's say a. Okay. Now, what if they have the same remainder, but we don't know what is the remainder? Now, this could be a problem, right? This could be a problem. But our ideas are still the same. That is, we try to get rid of the remainder. 3. How can we get rid of the remainder? How to get rid of the remainder? So because they have the same remainder, all right, guys, you can think about this. Since they have the same thing, so if we want to take away the same thing, what should we do? We can do subtraction, right? Subtraction is basically taking away the same amount, right? So divided by 4. Divided by 4. So actually, what you can do is, since we know that they all have remainder 3, remainder 3, remainder 3 when divided by n, right? So why don't we just do subtraction between them? That is, if I use 153 minus 81, now you see, we have remainder 3 minus remainder 3. What do I get? I get remainder 0, right? So that means if this I can get remainder 0, then I will, the 153 minus 81, sorry, when divided by n, will have no remainder, and it will be a multiple of the n, right? It will be a multiple of the n. I'm just giving an example here, right? It's not necessarily remainder 3. So here we have remainder a. It's the same thing. Since we have same remainder, let's just do subtraction and then we can get rid of the remainder, right? So in this case, we can say that, 72 is a multiple of n, right? So whenever we have remainder, especially when they are the same, good idea is to get rid of them. Okay, you don't want to see them. I don't like the remainders. I don't like the remainders. So same here. Same thing to do is if we use 81 minus 65, right? You'll see that it's also remainder a minus remainder a. So when divided by n, they will also give us no remainder in the end. Right? So we can get another conclusion. 16 is also a multiple of n. Right? So we come back to our conclusion now. That is, we have two numbers. They are all multiples. They are all multiples of the remainders. Sorry, they're all multiples of n. So how can we find out the n? Just look for the HCF of 16 and 72. Right? Okay. Answer is not really 4. There are many different answers. For the HCF of 16 and 72, I think this is 8, right? So there are many different answers of this. N can be 8, or it can also be 4, or it can also be 2. Right? It works. It works. They all work. Okay. Okay, so this is the congruence. Yes, the answer is 8 or 4 or 2. If never specified, but it can't be 1, right? If you divide by 1, there will be no remainder. So and so this is how we solve the type of question with same remainder. Idea, kill the remainders. Okay? Always kill the remainders. All right, when you kill the remainders, you just have multiples, right? Which is a nice thing to have. Okay. So congruence problem is here. I think if I go further on this topic, it could get a little bit more too difficult for you. All right, so I would say the example is not that bad to understand. It's only talking about what I have shown you earlier. All right, so probably after today's live stream, you can try the example 2 questions by yourself. All right. So, oh, I forgot to rate. I forgot to do the rate thing here. All right, let's just rate this question, guys. The random question I wrote down here. What would be your rate? That's about the killing remainder process. So 1 to 5, how hard is the killing remainder thing? Actually, I would say everybody here is already doing a great job because we've gone through like 10 lessons, 10 normal lessons contents already. All right, so quite a lot to learn. Okay, 1 to 2. Okay, good. 2. All right. So this is not that bad. So guys, remember our main idea, kill the remainders. I kill the remainders. Okay, so example 2, you can maybe do it by yourself next time. And let's jump directly to the divisibility rule. All right. So everybody loves divisibilities. I'm gonna say everybody loves divisibilities. It's just people don't know how to use the divisibility rules. We are going to start with some easy ones, which is you can look at the last digits. Okay. So give me some example that you can by simply look at the last several digits to determine the divisibility. Give me some examples, like the easy ones. I'll give you example 2, right? 2 and 5, we can all determine the divisibility by simply look at the last 1-digit number. Right? Any others? 2. Okay, 5 and 2, yes, 4. Okay, very good. So if you want to determine the 4, how many digits we need to look at? We need to look at the last 2 digits, right? And actually same for 25. I also see somebody says 8. Yes, 8. Sorry, right? So for 8, you need to look at last 3 digits, right? 8 and 125. Actually, let me I'm not sure if you have learned this or not. Of course, 10. All right. So actually, these are just for those 1 digit. They can use the last 1 digit. They are just factors of 10. For those, now you need to look at the last 2 digits. They are the factors of 100. And for those you need to look at the last 3 digits. They are the factors of 1000. Okay, so these are the by simply looking at the last digit, you can get it. Okay. Now I see a lot of people says 3. What is the divisibility of 3? The divisibility of 3 is actually the sum of the digits. Right? It's actually the sum of the digits. So actually it's about 3 and 9. They are all factors of 9. Right? All factors of 9. You can use the sum of the digits to determine. Okay. Okay, and actually, I'm gonna show you a little bit more. For 11 and 99, right? You can all use. They're all factors of 99, as you can see. You can actually cut the numbers, right, into two digit, and then check whether the sum of the 2-digit numbers you get is a multiple of 11 or not, or it's a multiple of 99 or not. Let me give you an example. 8, 2, 1, 0, 0, 8, 2, 1, 0, 0, 7. Okay, for example, this number. If you want to check whether this number is divisible by 11 or 99, right, or not, what you can do is you can cut the number every 2 digits. Now I get 3 2-digit numbers, right? And then I have 82 plus 10 plus 07, which is 7. And I see that this equals to 99, right? So that's why I can conclude that this is a multiple of 11 and 99. Definitely, for sure. Okay? So this is the divisibility rule of 11 and 99. And actually, you can see the pattern. First group is 3 and 9. The sum of the digits is they're all factors of 9, right? And for the second group, 11 and 99, you have to cut into two digit segments. They're all factors of 99. Well, actually, we still have another one. We still have the group of 999. Actually, all the factors of 999, you can use the divisibility rule of 999. That is, you have to cut every 3 digit to check. Okay, guys. Now this would be a little bit too advanced for us, so I'm not going to talk about this one in very detail. If you're interested, just go ahead and ask your teacher. Now the last group, which will give us another way to test whether it's a multiple of 11. Okay. Who still remember how to what is the divisibility of 7? Guys, what is the divisibility of 7? Yes, how about 7? We had a question. How about 7? Right. So 7, 11, 7, 11, and 7, 11, and 13, they are in another group, right, which we call them is the difference group. So the difference group, the first one is once again 11. Right? So 11 can also be determined by this. That is, for example, I use my same number, A21007. right? I can cut every one digit, and then I start from the ones digit. I use 7 minus 0 plus 0 minus 1 plus 2 minus 8. So plus, minus, plus, minus, plus, minus. So basically, you start from the ones place, use the odd sum, use all the odd terms minus all the even terms. Okay, by odd terms, I mean the first term, the second, the first term, the third term, the fifth term. You see, I add all of these terms together, and then I minus away all the second term, the fourth term, and the sixth term. All right, so you see, this equal to 0, which is a multiple of 11. And that's why, all right, that's why we can also conclude that this is a multiple of 11. Okay, so this is for 11. Of course, we have the 101, which you are cut every 2 digits. Cut every 2 digits. And for the factors of 1001, you have to cut every 3 digits. Now, this is another thing that I want everybody to remember, especially if you are P5. Especially if you are P5. Okay. So, guys, what is the prime factorization of 1001? What is the prime factorization of 1001? Yes, we always go to the left from the right. Who knows the factors of 1001? It is very, very important to remember this. All right. So 1001 is actually equals to 7 times 11 times 13. Right? So yes, 7, 11, 13. So all these three numbers, the divisibility rule, we can use, cut every 3-digit numbers and make the difference to find it out. Okay, so let me just again randomly write down some number, maybe 9, 8, 5, 4, 3, 1. Okay, now this is not that easy to calculate because you'll get some negative numbers. Let's flip it around. 1, 2, 3, 6, 7, 9. All right, 1, 2, 3, 6, 7, 9. Okay, so how do I check the divisibility of this one when divided by 7, 11, and 13? Is I can cut every 3 digits from left, from the ones place to the highest place, right? And then I use the first term. I plus the first term minus the second term. Again, I plus all the odd terms minus away all the even terms. So I get 679 minus 123, which will give me 556. Okay, guys, is this a multiple of 7? Now you now you're dealing with a much smaller number, right? Instead of a 6-digit, now you're dealing with a 3-digit number. So if you want to check whether it's a multiple of 7, just use 556 divided by 7, and you will get 7 T9 remainder 3. All right. So that's why we can conclude this 1, 2, 3, 6, 7, 9. It's not a multiple of 7. And more importantly, we can use the divisibility property to help us find out the remainder, not the original number when divided by 7 also have the same remainder 3. Okay? All right. So guys, whenever you get a number, you can always use the divisibility rule to help you find out the remainder easily. So let's do some practices over here. I will give you some numbers we have. Okay. I want you to to do it fast, tell me what is the remainder of these numbers I write down when divided by 4. Okay, remainder when divided by 4. Let's do some quick practices over here. We start with 3952 divided by 4. What is the remainder of this one? Please use the divisibility to help you a little bit. Remember, the divisibility of 4 is looking at the last 2 digits. Yes, very good, right? But look at the last 2 digits. You'll see that 52, when divided by 4, has no remainder at all, right? So that's why the original number also have a remainder 0. When divided by 4. Okay, let me give you another bigger number. Let's say 7, 3, 6, 1, 6, 2, and 5. So guys, when this number divided by 4, what is the remainder we get? A 0? I think people spamming the 0 are still talking about last question. Very good. This time, it has a remainder 1 because 25 divided by 4 have a remainder 1. Right? Okay. Now, how about 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Let's just stop here when divided by 4. What do you get? We get a remainder 1 again because 89 divided by 4 has a remainder 1. Okay? So this is using the divisibility to help you find out the remainder in a quick way. Of course, guys, if I ask you, what is the remainder of, let's stick with 71625 when divided by 9. What is the remainder of this one? What will be the remainder of this number? Let's see. I try to recall the divisibility rule of 9. It can help you a little bit. Well done. I already have some people get the answer. That's 3. 3. Okay. Oh, guys, it's actually 3. It's actually 3. So let's see how. Okay. When we divide by 9, it's no longer looking at the last 2 digits. The divisibility rule of 9 is we look at the sum of the digits, right? So here we need to sum up the digits. 7 plus 3 plus 6 plus 1 plus 6 plus 2 plus 5. Okay, and then use this to divide by 9 to see what is the remainder. And you'll see that the remainder is actually a 3. Okay, so please use the divisibility wisely. Okay, it can help you a lot, save you a lot of time. Okay, so yes, we can talk about the divisibility rules for a very, very long time, right? For a very, very long time. So I would say the question here, they are not terribly bad, but I'm thinking about doing just one question over here. Okay, I'm thinking about just doing one question over here. That is, what a 7-digit number A2017A4 is divisible by 12. What is the sum of possibilities of A? So 12 is it's not really like any of the number that we have done, right? It's not like any of the number we've done. It's not even in my table. If you look at my table, it's not even in my table. But this, when we see a composite number, we should think about the factors of this number. All right, 12 is 3 times 4, right? 12 is 3 times 4. So that means we can use the divisibility of 3 and the divisibility of 4 to have a check, right? Which one is possible? Okay, so divisibility of 4 and the divisibility of 3. Now, guys, which one should we try first? Which one should we check first? Divisibility, guys, if you, oh yes, if you want to see the table, I'll definitely show you later, okay? The divisibility of 4 or divisibility of 3, which one should we check first? Which one is easier for us to check? Very good. 4, right? When you check the 4, you don't have to do the calculation. Just look at the last 2 digits. Just observe, right? So that's why we start with 4, divisibility of 4 first, and then we think about what does the number we get actually satisfy the divisibility of 3. So last 2 digit, A4, it must be multiple of 4. Okay, so what are the possible values of A? What can A equals to? If A4, the 2-digit number A4 must be a multiple of 4. What are the possible value of A? Well, people on YouTube, time to answer the question. Okay, where people says 4. 2, 4, 6, 8. Excellent. Actually, I have forgot one very important one, 0. But 0 is not practical in this question. Right? Normally, 0, you should consider 0. But 0 is not practical in this question because A is also the first digit. Right? So 2, 4, 6, 8, we only left with this to check. We only left with this to check. Right? Yes, A is the first digit. So 2, 4, 6, 8, they all satisfy the divisibility of 4. So we need to check whether they all satisfy the divisibility of 3, right? So if we can start with if A equal to 2, then what is the sum of the digit? A equal to 4, what is the sum? A equal to 6, what is the sum? And A equal to 8, what will be the sum, right? So you have a try. If A equal to 2, the sum of the digits will be what? What will be the sum of the digits if A is 2? If A is 2, right? The sum of the digits will just be 18. Okay. Now, is this a multiple of 3? Absolutely, this will be a multiple of 3. Okay. Hey, people on YouTube, okay, please answer the questions. Then how about A equal to 4? A equal to 4, we're just adding a 4, so 22. Not really a multiple of 3, so we can cross out this possibility. I equal to 6. That'll be 26. Still not a multiple of 3, so cross out this possibility. And then finally, if A equal to 8, we will get 30, which is once again a multiple of 3, right? So that means if A equal to 2 or 8, the conditions are satisfied. The conditions are satisfied, and we can say that, well, this 2 and 8 are our answer, but it's looking for the sum. So our answer will be 2 plus 8. That's 10. Okay. All right. So, guys, people on YouTube, please stop spamming the chat box. I cannot see people's answer. And I would say it's the time to rate this question again, right? So you've learned a lot about divisibility rules, and please use all of them wisely. Use all of them wisely. It can help you find out the remainders. It can also help you determine what are the missing numbers here. Okay, so let's rate again. Rate time. Let's see what is the most popular rate. By the way, 1 is for easy peasy, 5 for killing my brains. 2, 5. Okay, 4. All right, I guess majority of people are giving me 3. All right, so that's a lot of 2, 3s. Yes, okay. Also a lot of 5s, I can see. Sure, let's just say it's a 3, okay? So let's move on. Now this topic is done. We're left with one final one that is about the factors and multiples. All right. So this is a quite heavy topic, quite heavy. If you are in our class, if you are studying with our teachers, you'll see that well, probably you'll see 4 different lessons in this topic, right? The basic factors and the multiples, the LCM and the HCF, the number of factors, right? They're all here. They're all here. So that will be 4 different lessons here, right? So today, clearly, I will not be able to cover all of them. So let's just take some examples for me to go through, okay? And I think, yes, today we will just end around maybe 4 p.m. sharp. All right. So let's start with the properties of factors. Or I should say, what does factors means? I will always start with the definition. What are factors? What are multiples? The factors is a number that can evenly divide another number. Right? So for example, here we said if n is a factor of n, then that means, well, n, the number n can be written as some number, maybe 4 times 3 times n, maybe 4 times n, but some whole number, integer, times n. All right, now this is called a factor. Of course, we can also say if n is a factor of n, then n is a multiple of n. Right? And it's mutual. It's mutual. It's the same. Okay. It's well n and 4, not 8. Oh, you are killing me if I n and 8. Okay, so today I'm gonna show you a new notation that is a straight line. Right? You can say it's a straight line. That n, if n is a factor of n, now we can write it as n line n. Okay, this is called n is a factor of n, or otherwise we can say it's n is a multiple of n. Okay, now there are some important properties of factors. Now you can find it here. You can find it here. It basically says if a is a factor, for example, if 5 is a factor of 10, 10 is also a factor of 100, right? And we can easily conclude 5 is definitely a factor of 100. This is called the transitive. Okay. Of course, you don't have to remember the transitive. Just remember that if you are a factor of a bigger number, and a big number is a factor of an even bigger number, then you're definitely a factor of the bigger number. Right? And also we can say that if A is a factor of B, B is a factor of A, then they are the same, or they are the opposite number. Where since you haven't learned the negative numbers, I would say just ignore this. Right? Just ignore this. And of course, if I have 5 is a factor of 10, we know that 5 is also a factor of 35, right? So actually, I can also conclude 5 is a factor of either 35 minus 10 or 35 plus 10. Okay? This also works. This also works. All right. So this is the property of factors. And also we have the HCF and LCM thing. I mean, you're all very familiar with the HCF and LCM. Right, so let's just stick. Just review your books. Right, either you learn in school or you learn in Sync Academy. Just review your books. You definitely have learned the HCF and LCM. I'm gonna skip this. And dear, all right, and for the factor theorem, for P5 students, please make sure that you get the factor theorem, right? We have learned the factor theorem already, and it's very, very important topic. Today, because of time limit, I would say the factor theorem, it's not mandatory if you haven't learned this, but if you have, right, guys, remember that first of all, first step is we need the prime factorization. And the second step is we look at the exponents, right? And then we add the exponents by 1 and times them together. For example, 12. 12 is 2 squared times 3, right? So the number of factors will just be the exponent 2 plus 1 times the exponent 1 plus 1. So that'll be 6. Okay? So this is something that we have learned. If you haven't learned this, please find a very detailed explanation. Because if I want to explain this topic, right, itself will take me like 30 to 40 minutes. So I would say I'll just talk about the formula, how to use it. Maybe I can show you another example about this. Okay, about how to use the factor theorem to find out the number of factors. So guys, let's just do the 2025. I'll come back to the question again. Who still remember this? What is the prime factorization of 2025? I ask you to remember it, right? What is the prime factorization of 2025? Anybody still remember this? Uh, 45, yeah, it's 45 square, but it's not really the prime factorization. It's 45 square. It's not really the prime factorization. But yes, let me write it down. The prime factorization will be 3 to the power 4 times 5 square. Right? So here's another thing that you could possibly remember. That how many factors does it have? It has, again, we look at the exponent 4. 4 plus 1. Look at the exponent 2. 2 plus 1 times together. All right, so it'll be 5 times 3. It has 15 factors. It has 15 factors. Okay. All right, so this is the factor theorem. Now, the Explore 2 question will be totally about the factor theorem. So, so I would say maybe follow the pattern, study the Explore 2 by yourself. right? But for Explore 1, today maybe we can do the Explore 1 and end our topic here, all right? All right, suppose A, B, C are whole numbers such that A times B is 24 and B times C is 52. What is the smallest possible value of A plus C? Now, you see, how can we make our A and C small? If we make our A and C small, right, we have to make our B as large as possible, right? As large as possible. But a common problem that you guys might have is, well, when you see this, you see a common thing. But guys, I think many of you will not think about the factor, right? So whenever I write, for example, 24 as 8 times 3, what does this mean? This naturally means 8 is a factor of 24. 3 is a factor of 24. Or I should say, or in another way, I can say 24 is a factor of 8. 24 is a multiple of 8 and 3. Right. So whenever we see two numbers times together, whenever we see a product, okay, think about the product, think about the factors. Think about the factor. Okay. So as here, we can just think about, well, they have a common factor of B, right? So why don't we just find out the HCF of these two numbers, 24 and 52. So what is the HCF of 24 and 52? The HCF of 24 and 52 will be, if you use the white letter method, or if you are very familiar with the prime factorization, you're very familiar with the times table, and say that this is just 4, right? So if we want to make our B as large as possible, we definitely want our B to be the HCF. So take B as 4, and naturally we can find out what is A. A is 6, and C will be 13, right? So this is the smallest possible value of A plus C, 4 plus 13. Okay. Okay, guys. I would say this is for the example 1, right? For example 2, it will be an application of the number of factors theorem, right? The number of factors theorem. Well, guys, actually, don't worry about NMOS. You're not cooked for NMOS. You're not for NMOS, right? Normally, this year we will have 35 questions. Hey guys, have a guess. How many questions you need to get it correct in order to get a gold medal in last year? Or say 35 questions, 85 points. How many questions you need to get it correct to get a gold medal in last year? In last year's almost. Let's see. Anybody want to have a guess? 20, 17? Yes, roughly. Actually, if you can get like 17 questions correct, like around 35 to 40 points, right? That's like half of the point. You can already get the gold medal. Okay, so guys, don't be very worried about the almost. Make sure that you understand the basic questions that we have talked through in today's lesson. Right, the number series, And um, more importantly is you understand the concept, you get some practice about similar questions that we have at the back, right? I'm sure that you still have like half of the year to improve yourself before the NMOS. And for 4 months, 4 months. Okay, so guys, I would say that's the end of today's webinar. If you have anything that you want to discuss, any question, right, you can discuss with me here. And by the way, before you leave, please rate. Please rate today's questions one more time from 1 to 5. How hard would you rate today's question? This is our like final rating before you go. 5, 6. Okay, kind of easy. Yes. Almost normally don't test very difficult number theory questions. Okay, so do get some practice. Of course, if you want to see the table of divisibility I had earlier, here you go. You can take a screenshot of the table. Hopefully, it helps. One. Okay, yes. All right. So if you don't have another questions, then I guess tomorrow I'll see you at the same time for what problems. Okay. IMO is harder. IMO is definitely harder than NMOS. But the problem with NMOS is you only have limited amount of time. All right, for 35 questions. So you have to be very, very familiar with the concept, the basic questions to get like half of the questions correct. All right, bye guys. Bye guys. If you have no other question, I'll see you. Yes, if you have question, please just type in the chat box. I'll see what is your question. Okay. Uh, yes. Oh, combinatorics is like extreme value problems. The type of problems that is very hard to classify into the calculation, the number theory, the geometry, those type of questions, like logical reasoning type of questions, we call them the combinatorics. So it will be more like having a logical reasoning thing. Okay. When we talk about the combinatorics, of course, it could be difficult. It could be difficult. But some of the topics are not that bad. Some of the topics are not easy to learn. But we will see the combinatorics one later in Friday. Okay. Yes. Welcome. How much time is given for NMOS? I think this year and the last year, the NMOS is 1 hour and 30 minutes. You will have 35 questions. So on average, you only have 2 minutes, uh, a bit less than 3 minutes to answer each question. You have 90 minutes to do 35 questions. All right, so the time is very tight. Yes, if you have like questions with IMO, you are welcome. You are very welcome to ask your question in our group. We have a lot of teachers in the group that they are very willing to answer the questions. I will also be there answering your questions if I see your questions. Yes, what problems will be the topic we have tomorrow. Actually, it's work problems and also about journey work problems. But should be fine. Should be fine. Okay. Bye. Uh, and almost. Sorry, no, you don't have the multiple choices. You only have you only have the filling blank questions in almost. Okay, you have to write down your answers. Unfortunately, you can't have a guess. How to get into the group? Well, I don't have a QR code here, but you can contact teacher Xingyi to get into our WhatsApp group. And what is teacher Xingyi's number? I think you can just send a message to us on YouTube. Yes. And oh yeah, it's here. What are the most common questions if you're talking about in almost? That will be the work problems because normally work problems will be slightly easier than another questions, right? So you see, almost you don't have a lot of time to do the difficult questions. So most of the questions will not be that difficult. They will focus more on the geometry and the work problems and also some of the calculations. Um, if you ask specifically which topic is most frequently asked tested in almost, that would be the racial work problems. A lot of racial will be tested. Okay, so please study the racial work problems well. It is very important, and please don't forget to attend tomorrow's webinar, tomorrow's lesson, which will be about work problems. Okay. All right, so I would say that's all we have for today. Um, I'll just see everybody maybe tomorrow. Okay. All right. Bye bye. Bye guys. What is ratio? You'll see tomorrow.